Bueno, para empezar, buenas tardes a todos. Muchas gracias por...
Good afternoon. Thank you for being here. I would like to thank INVenTs for inviting me to be here. Let's begin. What am I going to speak about? Introduction to NVT. Are you familiar with this concept? Do you know what it means? It's okay, that's why we're here. Industrial devices. My talk will be focused on industrial topics. Maybe you come from the IT world, but we'll focus on operations. How are we going to create the NVTs? We're going to have NVTs everywhere, industrial NVTs, and then demos. That's what everybody likes. We'll have fun. I've already been introduced, but I would just wanted to say that I'm a consultant at S21Sec Nextel. I have some certifications, international certifications related to cybersecurity, industrial cybersecurity, and I work with the CCI. What's an NVT? They are network vulnerability tests, tests with which we can obtain evidence about vulnerabilities and aspects that allow us to use exploits. They're written in NASL language, which is Necessary Target Script language, that allow us to check the existence of vulnerabilities. Why are we using NASL or instead of Python or any other scripting language which is available in the market and many of you are familiar with? Basically, because it was designed for this purpose. NVTs are developed with NASL because NASL was developed in order to do NVTs. It saves time compared to other script languages, and there's a control on the code, so we can prevent that someone injects some malware, malicious code, malfunctioning within our code. Everything is very controlled, unless we create a package, but that would be on purpose for a more advanced testing. Why do we use them? Why are we going to use NVTs? Because of FAT and SAT tests. Are you familiar with this type of tests? FAT tests are tests carried out before implementing a technology in a production environment or a facility, and SAT tests are carried out once the device has been installed and production is working smoothly. Why? Because we reduce times when it comes to obtain vulnerabilities. We can automatize the execution of tests, we can create procedures, and we can carry out stress tests and fuzzing. We'll see this later on. We will create packages in order to simulate, detect abnormalities, abnormal behaviors, etc. Who uses NVTs? Well, I understand that you may be familiar with OpenVAS. Yes? Yeah, I see some people who knows about this. It's a platform, or tool rather, useful to obtain information about the vulnerabilities. You can analyze an environment, a network, etc. Why am I showing the number of NVTs? So that you can see that there's an active community that develops this type of tests. I'm not a crazy guy who got up here to speak about NVTs. There are many people working with this, and they're very good. I guess you're familiar with Tenable. They also develop NVT. There are quite a few NVTs developed by Tenable. In their industrial area, they had 301 plugins. They were developments They use Python for some things. They have powerful platforms. They used to have 301 plugins, and now they have 6,000. Just from an industrial point of view, I'm sure there are many others. Then you have search engines. You can search for NVTs depending on different aspects. Where since we're speaking about OpenVAS, this is how it's structured. These are customers, visual customers. We can set up the services we have running, administrator, manager, and scanner. We set up all this, the scans we want to carry out. We refine them, we fine-tune them, and we set our goals. Results and configurations. Of course, we have the manager and administrator. They share data, and the scanners feed on NVTs. The tests they have to carry out. The NVT tells you what you have to do and how. It's been developed by ourselves or whoever it is. We can use NVTs developed by other people. Environments in order to develop NVT. At the beginning, when I started developing NVT, I saw that you can use Vim, Nano, old school, or you can use Sublime, Notepad++ for comments, loops, structures of the scripting language itself, descriptions. As a tool, you can check, did have full Tenable, they have all the tools there and some others that you can use in order to promote your developments, that they're not so burdensome. You can use any editor, but it's nice to have things in different colors and structure, etc. Industrial devices. Are you familiar with the industrial world? I see some people that do. PLCs allow us to automatize processes. They have digital and analog input and output. They can have one or more. The PLC was bought in order to automatize. Instead of doing things manually, it was going to be faster and in a serial way. RTU are some sort of PLC, but they're different. This is seen in places with no continuous administration. There's no continuous operator there. And then HMIs, human-machine interfaces. They show information for the operator, and the operator can interact with the process in order to regulate some measures. Actions to be carried out, more pressure, less pressure, whatever. And a very famous system in the industrial world is SCADA system. I think they mentioned them yesterday. This type of system carries out supervisory actions. They allow you to centralize signals, so the operators can have the logics of a process in a single room, and they contact operators. They decide whether there's some sort of abnormality in the process, and they keep the system available. In the industrial world, availability is very important, and every work carried out in the industry is aimed at maintaining availability. And this type of environments, the protection of people is very important. In a robotic arm, if you get a virus, probably it will move very quickly and it may even kill a person. You have to bear this in mind. And they communicate with many devices located at different places. PLC, RTU, HMI. There are different levels of automatization and devices, and instruments, networks where you can find PLCs. You need to see how this is going to evolve. We're going to speak about the different parts so that you know what we're speaking about. SCADA at level 2 of automatization, which is supervisory network. Level 3, mesh systems, operation networks. And level 4, this would be focused on IT. We have LRP. You've seen the pyramid, and now at network level, we're going to see where every device is, where each device is located. Perhaps you're used to corporate network, where you can find many devices we have at home, for example, or right now, mobile phones, printers. We may share files in the network, our computers, but then we will focus and the test will be carried out, will take place at control network level. Remote, RTU, PLC, and level 2 automatization, HMI, supervision, SCADA, software, industrial software, etc.
And now, this is the scope of our testing. These devices, where these devices are found or are located in the network. So how do we create an NVT? So you need to have some fundamentals to create an NVT. So we have, first of all, a knowledge base with which we can interact through a number of functions. Then I will tell you where all the documents are available for you to check all the possible functions. And this knowledge base is kind of like our brain that we will be feeding with information so that we have an understanding of our device, so that we can find out about its vulnerabilities. Imagine that I fill our NVT with information. It is like a card. And I put all the information of the card into my brain. Then I create a second NVT, and then I relate them. And then a very important concept when it comes to creating an NVT is the following. If I create NVT1, and then if I fill it in with information, this is information that I cannot use in the very same NVT. So that means that I have to link the various NVTs. So in NVT1, I detect that port 80 is open, but it is also vulnerable because it has whatever Apache version. And that information, as said, cannot be used in NVT, but instead I have to create a NVT number 2 to use that information. So that is to say, the NVTs cannot use the information that they are fed with. Well, I hope that everyone has understood me. So I hope that you can follow, okay? Okay. So did you get that? Okay, good. Now, documentation. Where can you find documentation and information to develop NVTs? So we have the OpenVAS, then also the NASI reference manual, where you can check all the loops, all the structures, all the languages. So useful tips. check if there is an existing NVT. So you don't really want to waste your time. So if someone has developed an NVT, you may improve it with information in it so that you can create a second one, perhaps a more powerful one, or, well, a different NVT, drawing and building up on the information on NVT number 1. Then including all dependencies and requirements of our code. What are the dependencies that my NVT will have? For instance, open port, or I need a specific tool. Later on, we'll see that we may use different supported tools. Then also being aware of the QoD, that is to say, quality of detection. Quality of detection will be discussed later on. And that will mean that our NVT may have 80% or 90% level of quality. Then use an updated template. NVTs always have the same structure. We'll look at that later on. So if you have an updated structure and the structure that you improve on a daily basis, it will be easier for you to use all the information in NVTs that will be available whenever a vulnerability appears. Then using tools such as Wireshark, web browsing proxies to better understand communications and for better reproduction of them. You may, for instance, capture information with Wireshark through cut and paste, and you may send that information in raw. So at the end of the day, it's cutting and pasting. If you see that something is generating an abnormal behavior of there is a denial of service, you just cut and paste it and you send it in, and that's it. It's already created. As simple as that. Information to be taken into account. There is an identifier. So this is structure for you to create your NVT. I just don't have time to go into greater detail. And now tools that are to be taken into account to develop an NVT. Well, you may use OpenBus, Tenable, again, scripting language. So they all have this scanning option. The idea is to scan and to get your information. Also, you have to be aware of existing libraries for you to implement your own code. You may create your own functions, improve existing libraries, create new libraries. Tools. When you want to create regular expressions that are often very powerful, well, you may use this one, which is quite useful. And then, well, there are tools available out there, such as SNMP Get or SNMP Walk. Well, and I say, oh, this is really interesting. Okay, therefore I will tell you more about it. So our friends were Wireshark, also the proxies, Pescara, THAP, and we also have dissectors like Kaitai or Lua running under Nmap, as well as regular expressions, and as well as many others. This is the interpreter we are going to use. So it is not worthwhile to upload it to OpenVAS or to any other tool, because you will have to assign them. So therefore, let us take advantage of the existing interpreter for quick testing, which is not only the objective of this presentation, but also of our testing. Then quality of detection. On your left, you see the value of a remote banner. I don't know whether you can read it or not, but here is this remote banner is 80%. So this is a screenshot of Vulner's website where there are several feeds about vulnerabilities, exploits, etc. And it has been filtered through OpenVAS. And these are all for detection. So because industry prioritizes detection. So what you want to have is a directory of assets, so for you to be aware of the available devices. So being aware of all the devices in your industrial facility is not easy, and many companies do not have an updated directory of devices. I wouldn't say that all companies are lacking that type of register, but very many. So that's why detection is of high priority. We should take into account that the minimum percentage of quality of detection has been set at 60% before it goes into report. So this is an important characteristic. So if you want to include your INVETs which have quality of detection below 70, will not be in the reports. So if you configure your scan and then you get a good summary, for instance in PDF formats or any other formats, it will not be included in the reporting. Remote banner, 80% quality of detection. Now scripting with Nmap. Some industrial examples. These are specific industrial protocols, PACnets in smart buildings, Modbus, very widespread, S7 proprietary from Siemens, and ENIP NSE, used by Allen Bradley and other manufacturers. This is a GitHub of digital bond, including these scripts as well as many others. You can play around with them. Go through Nmap, careful with where you go to, because if it is a real industrial device, you may get into big trouble. So signing INVETs. This is for you to know that when you want to include your INVET into a tool, you have to sign it. Otherwise, the tool will tell you that you are not authorized to run it. At the end of the day, there is always kind of control. So both the code and running of your INVET is controlled. So GPG up. Now, elements to take into consideration for development of industrial INVETs. Possibility of sent out poorly created threads for stress testing. It is always advisable to run this type of tests in labs, never under production. Well, because if we were to do that, you could be in big trouble. Then unstable services that do not respond to some queries. Sometimes industrial devices may not keep up the life cycle of communication. They may go down, they may go on and off, they may be a bit unstable. So we have to take that into account. If your INVET tells you that port 161 should be open, perhaps that service will be very unstable in that very same device and may tell you that it is not open, but it may be actually open. So using the same INVET for scanning of a whole network, okay? Use them one by one and with care. When you use OpenVAS or Nessus, please do not use all the plugins families. So you have to take it easy. And then the life cycle of sockets. and that of the actual communication. Sometimes the life cycle doesn't last very long, or the device does not make proper interpretation of the communication, and then availability comes first in the industry. Some INVTs have an impact on the availability of the device. So you may be aware of a slow lollies, BERT, and it opens up sockets, etc. So we have to be very, very careful with that. And as I said before, carry out this testing in labs, not under production. So what are helpful logs? Well, these two ones at the bottom are very helpful, because here in OpenVAS the messages we will have information about objectives, the time where the INVT was launched, but the most important one will be the OpenVAS, the dump. Here we will have a log of scanning errors and messages, but messages all display. It means that there is a function inside OpenVAS dump where you can do printf or any other command, where you can comment and say, well, this is happening here, and then you will get that later on in your log. When you go through your script, you take a look at the different steps. Okay, oh, it doesn't go into the loop, or it is not calling the function. All right, so some examples from industrial INVTs. I like to separate that in three. So this INVT is associated with Siemens. So this is the copyright. And this is the description that you could get in the tools, but we are not very interested in that. Yet, if you have any questions about it, please ask me later on. And this is what we are interested in, the code. So this time we were detecting FTP, we checked the regular expression, and that was associated with Siemens Simatic. So this is for detection, PBS base, which is 0, and that's it. Then Schneider, same procedure, same structure. This is what we are interested in. Well, it says that this is a vulnerability for command injection, but the only thing that checks here is the version. And then it says this version is vulnerable. Doesn't do an actual injection. If you want to do the injection, we will base that on our CVSS. And I said, well, this is vulnerable. I'm going to inject it with my code. So the CVSS is of 10 this time. This is very important at industrial level, because with a denial of service, for instance, imagine that it has been classified as 6, and you can make something going out of production. So therefore, you have to be very careful to see where it's plugged in, what is the power system. So industrial power system, if receives a denial of service, you may be powering off 100 of industrial devices. So you may create like huge trouble. Now, communications. There are also INVTs for communications. This is the detection of Ethernet, and these are the threads that you may send. Well, I don't have to go through all of it. So we have the section of the product, the code of the product, manufacturer, type of device, the revisions. So we get information this time through Ethernet protocol. And now demo. This is the part that you most like. So I brought a video with me, because it's just impossible for me to bring all the devices. So this is Nmap scanning for you to see available ports. Then we get information. So different protocols, Ethernet IP. So this is what we saw before. So because we are doing bad with time, I will move on. So here you see how it interacts with the actual system. This is scanning. MAC address is associated with Siemens, and then we start to see strange things. It says that the device has been manufactured by Rockwell. Another part of scripting, this time with protocol S7. So this is for you to see the output of this script. Now we are obtaining information, interaction with it, more information now. While the system is Technodrone, this is the serial number identified in this facility. Then scripting and obtaining information. Before you attack something, you really need to know where you are, and especially in industrial environments. It is not only about attacking, but it is about being accurate in your attack. So if you are being offensive, you just don't want to be caught. So these are the slaves that are associated with the device, the Modbus slaves. And now we are running our INVTs. These are linked INVTs. So here we see some dependencies. -X is asking you to run it, despite whether it has been signed or not. So we have this port, because I really need to know whether there are open ports or not. I want to know also about the version that is being used, and final INVT, which shows here on the screen, and then the objective 192. I just don't want to be attacked by anyone on the internet.
Entonces,
This one takes a while, so I'll try to bypass it a little bit.
bueno, vale, aquí ya va sacando información. Hay algunos NVTs, por ejemplo,
We have some information here that some NVTs which are slower, the ones who go through VT, and it's because of this, because perhaps we're using tools such as Nmap, and that's why you're slower. So a bit faster. Did it detect the community? Yes. If you see here, you see set keys. It sets information. It's setting the cave, the one we've mentioned, or sorry, the KB we've mentioned before. The OIDs have their own ID. Yeah, there are some tables where you have the manufacturer's name, etc. Using this tool, I tried to explain the tools and then use them. I got information from the manufacturer, the module in which it is, and this is a Modbus development because we want to carry out tests. We're going to create packages and let's see how it interprets it.
Vale, bueno, estas son las respuestas de Modbus.
This is the Modbus response. I just have 15 minutes left, so I'll go quite fast here and then I'll get into detail in the most technical part. Here we're creating, I have this slide, I'm going to show it later on, so don't worry. What you can see here is that the device is not responding properly, so it's either badly implemented or there's something going on. Have you seen anything? I don't know. Well, I'll explain it later on. So more requests. What I want to do is analyzing the behavior of my device. So I do things, I change the values, etc. These are Modbus requests.
Bueno, esto sin más, porque son diferentes pruebas que veremos.
So a bit faster. Another INVT, but this is too much. It's a honeypot, yes. You've seen it. You cannot read it very well from there, but it says comport, so it's clear. So, something important. This is a display I included so that we know the ending point of the code. I wanted to explain everything and now getting into practice. I hope it's interesting. So now that we have so much information, we're going to put this into our KB. This is our tool. It carries out requests with S7 protocol, different communications, and what we try to do is knowing what device is behind this, because very often you're given an IP, but you don't know what's up there, you don't know anything. Sometimes it's not even communicating. Perhaps it's an industrial device which only generates a signal when you switch it on. It's complex. I just wanted to see the whole procedure. And what are we doing at Modbus level? We're sending a code in order to read the identifier of the device. I need to know what device we're speaking about. Why do I know that it's interacting in the wrong way? We're requesting this. We're sending this request. This was one of the threads. And there are different things you can use. I'm using 10. 10, it's not there. Therefore, if it does not exist, the answer, according to the Modbus logics, the way this protocol is implemented, I should be giving a failure. And it answers that everything is okay. I change the values, and here it's saying, it's telling you the different objects there are. I have 3, Siemens, Simatic, and S700. I'm going very quickly over this, so I apologize. If you have any doubt, you can ask me later. This is the answer. And here you see the objects, the IDs. There are 3 objects which are mandatory. And the conformity level, that shows you the way the protocol works and the answer you need to receive. And bearing all this in mind, and the fact that these 3 fields are completely mandatory, this is a wireshark thread, it could be copied and pasted, and you send it. That's why using scripting is very powerful. This is the trick. Modbus, this is the reference. In our Modbus, it's an open protocol, so anyone can see how this is implemented. I know that the device's parameters, ID, are 1 to 4. Here it says that if the value is bigger than 4, you need to give me, you need to tell me that the data is not valid. This is what everybody does. So I know there's something going on there. Another idea at the network level which can make me think that there's something wrong going on here, because you're saying, well, this guy brought a compote and you know this is a compote, but let's see the communications. It uses the same structure. In industrial devices, NIPs, which is the information obtained thanks to SMVP protocol, NIPs can be private. With the private NIP, you can get more information, and NIPs change. This is from the same family. Here, this could be an industrial device, but it makes me think that there's something going on here. This is Modbus. This is all the information we got from the compote. In our KB, we can conclude that this is a honeypot, and this is a raspberry with the modified Mac. You know there's something weird going on, and you know that thanks to all this, you're entering information in your brain, which would be the KB. I thought it was very interesting. The master's in misleading people, he said, okay, HTML of compote has this and override. He said, let's write something before it, and he kept the rest. Well, great. Quite the master, but it was just some interesting thing. And then here's Shodan. This is a query you can send. There are 1,000 to detect compote, but Shodan, with its platform, detects this one. I'm sure there are many others, and there are more advanced honeypots that require a deeper study. All these tests have been carried out very quickly. That was why using scripting language NASL was so important, because it's quick. This is a real device, real industrial device, and it's very quick. The video is very short. It's an industrial device with a specific manufacturer. I'm not going to say it because it's there. Let's leave it at that. So you scan with map. And map in production, that's something you should never do. And here, I'm going to go old school. I'm going to use this. You open up communication and you send the request. Get to URL, whatever. And it answers with that. Can obtain is that the manufacturer is ZIV, that's it. So you move on. You investigate, you use other ports to get in, you improve your tests, and when you find the manufacturer, you press enter and you go have a coffee and you go back to find new vulnerabilities, new attacks, etc. This is the implementation from the INVT. You need to check that port 80 is open, URL, request to port 80 with this item, which is port 80, and here it interprets the headers. This is the body of the message. We could use a regular expression. Here we just check that this content is in the header. We put it into the display because we are interested in having that, and then you show it in KB. I have time. This is practical case. I just wanted to show you how in CyberCert, with that warning service, creates a series of warnings related to industrial cybersecurity, and I would like to show you how you can implement it very quickly. This is the warning. This is code says. I have several. I have to check the release, because it's quite easy. This one is 3511, and here it says, I can barely read it. It says before 3513. So you know that these two are vulnerable. Therefore, what should we do? Now you need to check how to follow the steps of the explanation of the vulnerability. You need that release, but you need those components stated there. If you search the internet, you'll find things. These are shown parts, and this component is a functionality which is included in virtually every code sys, but you need to make sure that it's that release and that it's using that. So it's XML, and perhaps it's not available at network level, or it may get complicated. So you may say, okay, I know the code sys is here. I know that I can know the release at network level, and I stop there. Because for this you need to carry out an investigation, and you have not enough time for that. You're a consultant. You're sent to a company, and you have a given period of time in a device. Let's the game start. If you've carried out some automatized tests, which can be automatized with the scripting language, with Python, I thought this was very interesting. You use these, you press enter, you carry out elaborate tests, and you have more time for other things, and that's always a good idea. And this was everything. Thank you very much.